Welcome to the Cloud Database Solutions hand-drawn guide. In a world where data is the new oil, most organizations are struggling just to keep their buckets from overflowing. We've built this course to take you from buckling servers to ironclad security, using a simple, layman-friendly approach. Over the next few lessons, you'll discover how to choose the perfect database engine, master the art of scaling without crashing, and unlock the serverless revolution that saves you money while you sleep. We've broken down complex architectures into approachable sketches, covering everything from the triple states of encryption to the secrets of global sharding. Stick around to the end, and you'll have the blueprint to build data solutions that are powerful, cost-effective, and safe for the modern information era. In the digital age, every click and card swipe generates data that organizations crave. But managing this big data is like catching a waterfall with a bucket. Traditional databases just buckle under the rapid growth. This guide breaks down how Azure Storage solves this by letting you choose the right engine for your workload. You can opt for the DTU model, a simple, pre-packaged bundle, or the vCore model, a completely custom, a la carte build for infinite scale. Forget the old days when a surge in web traffic meant a guaranteed server crash. Today, cloud databases can breathe, using elasticity to grow when you're busy and shrink when you're not to save you money. You can scale vertically by making your existing resource more powerful, like swapping a 4-cylinder engine for an 8-cylinder, though this usually requires a quick restart. Alternatively, you can scale horizontally by adding more cars to your fleet while it's still moving, which is the preferred choice for modern apps. For unpredictable workloads, the serverless revolution allows your database to autopause. You stop paying for the engine and only pay for the garage storage until it instantly wakes up again. Imagine trying to fit a phone book containing every person in the world onto just one server. It's simply too massive to handle. This is the big data challenge. The solution is sharding, breaking that colossal book into manageable pieces, like creating 26 smaller books, one for each letter. We can give each customer their own unique book or have multiple customers share one to reduce costs. The true brilliance of sharding is in safety. If one server fails, only that tiny portion is affected, keeping the rest of the world online and scaling your system endlessly. Managing a database isn't a one-size-fits-all task. Saving a new order is very different from running a complex report. To keep things moving, Read Scale Out creates a dedicated read-only copy of your data, much like an information desk that keeps the main checkout lines short. For companies managing dozens of databases, Elastic Pools offer a smarter way to work by letting multiple databases share a single bucket of resources. Instead of paying for 100 separate high-powered servers, your databases simply grab what they need when they are busy and give it back to their neighbors when they are done. Data security is more than just a password. It's about ensuring that even if files are stolen, they remain unreadable. We protect data in 3 distinct states. At rest, where information sitting on a hard drive is locked in a digital safe using master keys. In transmission, where data travels across the internet in an armored truck protected by TLS, turning intercepted info into gibberish. And in use, the most advanced stage where data is like invisible ink. Features like always encrypted scramble information even while it's being processed in memory, ensuring that not even cloud operators can see your most sensitive details. By combining this ironclad security with smart sizing and flexible scaling, organizations build powerful, cost-effective solutions for the modern era. In this course, we explored the massive challenges of big data and how traditional systems often buckled under the pressure of explosive growth. We learned how to choose the right database engine by comparing simple DTU bundles with the high-control vCore model. We mastered scalability, distinguishing between vertical power boosts and horizontal fleet expansion, while discovering how serverless tiers saved money through autopause. We examined sharding techniques to break massive data into manageable pieces and used Read Scale Out and Elastic Pools to maximize resource efficiency. Finally, we secured our solutions by implementing ironclad encryption for data at rest, in transit, and even while in use.